Next, let's look at the applications for electrochemical impedance spectroscopy. So under the applications menu, under EIS, we have a few different actions, mostly for plotting. And the first one is for making a Nyquist plot. And we can see that this will plot minus Z bis versus Z prime. And this works a little bit different than what we saw for battery and CV. So here we should select the Z prime and minus Z bis data series and optionally multiple tables. What this means is that we have to select the data series that we want to plot here, namely the real and imaginary components. And then we can, if we want, select multiple tables. So I will select these two here. And then I will choose this Nyquist plot. And then we will get the two impedance spectra in one Nyquist plot. And of course, this then has the scaling correctly, so the two axes are always correctly scaled. Now there is a second Nyquist plot, which says Nyquist plot reversed. And this might look like it's exactly the same as the first one. But if you look closely, the second one says plot Z bis versus Z prime and not minus Z bis. And this is then because in some cases, we have the negative imaginary component, as in this data from EasyLab. But in some cases, like in this data collected by Autolab, it records the positive imaginary component. And so in this case, if you have data like this, where you have the positive imaginary component, you should select the Z bis and plus Z prime. And then we can choose the second, the Nyquist plot reversed, to plot it correctly. And this will make the correct plot and just make a reversed y-axis. Next, we can also make some Bode plots. And here it says that it will plot magnitude and phase versus frequency, and we should select frequency, Z, and phase angle data series, and optionally multiple tables. So we have to select the frequency and Z and phase, and I'll select both tables here at the beginning. And then we can choose the Bode plot to make a Bode plot, and now we have the phase angle and magnitude separated on different y-axes, and the magnitude is on a log scale. Again, we had a second option for the Bode plot, and this again might look very similar, but if you look closely, this will say that we should select the frequency, phase angle, and magnitude. So the phase angle and magnitude has been swapped. And why do we need this? Well, for these applications, the data selection works by index. And here we had the magnitude before the phase angle in the data. This one is a 3-electrode spectrum. And if we scroll down to see the full impedance, we will see that here actually the phase comes before the magnitude. So if we want to plot the full spectrum here, we need to select phase and magnitude, and I also need to select the frequency up here. And then in applications, we need to select the second Bode plot because the phase angle comes before the magnitude. Now we get the correct Bode plot here with the magnitude on log scale. Finally, we have one more application, which is not for plotting, but for loading data files, and in particular for RelaxIS type exports from Nova. And this says it would load a Nova text export in RelaxIS format, and we should select the location and then choose the files to load. So we can select the folder or any file in the folder to place these new loaded files in this project folder. And then we can click it and choose the impedance spectra we want to load. So I have a few impedance spectra here. And then it will load the data files. And this might load correctly even with a default data loader, but if it doesn't, then you might have better luck using this bespoke loader. And it will also give you another table with the metadata. If I show the data, we can see that we, for example, have the temperature and DC voltage metadata here, which was included for each of the different spectra. So those are the built-in applications for impedance spectroscopy. If you are missing some application for equivalent circuit fitting or some other functions for impedance spectroscopy, it is probably included in RelaxIS, and that would be a better tool to use for that purpose. And in addition, as described in another tutorial video, under the data menu, you also have the process time domain EIS data, which has some functions to calculate quality indicators and make higher harmonic spectra, etc. So I can recommend watching that video if that is what you're interested in.